Continuing from previous session, quadrilateral, there is a third session. In the previous two sessions, first we have learned about quadrilaterals. In second, parallelograms. In third, there are four quadrilaterals I have drawn A, B, C, D on the board, where A is a parallelogram. So, what modifications in parallelogram will result in these three quadrilaterals? Now, parallelogram has three things. One, side, diagonals, and angles. Sides S, diagonals D, angles A. We will use this shortcut in this. Now, we know sides are parallel, opposite sides are parallel and equal. What if all sides are equal or adjacent sides are equal? If adjacent sides equal, this rhombus will become a, this parallelogram will become a rhombus. Means case 1, S equal, sides equal. So this became a rhombus. So if all sides are equal, it's a rhombus. Now coming to diagonal. There are two possibilities in case of diagonal. One, that the diagonals are bisecting each other at 90 degree, or they are perpendicular bisector. One possibility, because in case of parallelogram, diagonals bisect but not at 90 degree. So if diagonals are bisecting at 90 degree, one, and second, diagonals are equal, because in parallelogram, diagonals are not equal. So if diagonals are equal, then it is here, case 1, D equal. If diagonals are equal, then it's a case of rectangle. So this figure B is actually a rectangle. So in case of parallelogram, if the diagonals are equal, it will result in a rectangle. But if D bisect at 90 degree, then a parallelogram will become a rhombus. Why? Because in case of rhombus, diagonals are bisecting each other at 90 degree. So this is the case. Now in case of angles, if angles are, all the angles are equal, because in case of diagonal, in case of parallelogram, opposite angles are equal, but not the adjacent angles. So if these two adjacent angles are equal, and these two are adding to 180 degree, so automatically it will become 90 degree. So case 2, angle, all the angles equal to 90 degree, or all angles equal. A means angles. So I am taking property from here. So A angle is equal to 90 degree or all the angles are equal. In that case, a parallelogram will become a rectangle. Okay. Similarly, from rectangle to square, if all sides are equal, any one of these two property will make a rectangle square. How? S equal. S means sides. So if all the sides of a rectangle is equal, then it will become a square. So this is nothing but square. So case 1, use any one of these two. Any one of these two property if you use here, and if we use any one of these two here, a rhombus will become a square. How? Let's see. If sides equal, so in case of rectangle, case 1, sides equal. Obviously, rectangle sides equal will become a square, and diagonals bisect at 90 degree. In case of rectangle, they don't bisect, but in case of square, they bisect. So case 2, diagonal bisects. Bisect at 90 degree. Now, in case of a rhombus becoming a square, rhombus has all 4 sides equal, diagonals perpendicular bisector, but if any one angle is equal to 90 degree, then this rhombus will become a square. So, taking the second property, 1 and 2. 1 says diagonal equal, 2 says angle equal to 90 degree. So, in case of a rhombus, if any angle is equal to 90 degree, this rhombus will become a square. So, this way, the main 4 these quadrilaterals are linked with each other. It simply means every rhombus is a parallelogram. Every rectangle is a parallelogram. Every square is a parallelogram. Every square is a rectangle. Every square is a rhombus. But every rhombus is not a square. Please understand it. Only those rhombuses are square if either the diagonals are equal or any one angle is 90 degree. So this way, these 4 figures are linked with each other. Now, is there any other possibility that a parallelogram is a rectangle or a parallelogram is a rhombus? Let's see that. This is with respect to side, diagonal and angles. Now, next step. There is something called cyclic quadrilateral. Now, what is a cyclic quadrilateral? Inside a circle, if there is a quadrilateral, this quadrilateral is known as cyclic quadrilateral. In this case, if we name our quadrilateral P, Q, R and S, then this quadrilateral is known as cyclic. It means all the 4 corners or the vertex of this quadrilateral lies on the circumference of the circle. The property of the cyclic quadrilateral, opposite angles adds to 180 degree. So, P plus R will be 180 and S plus Q will be 180. This is a cyclic quadrilateral. Or in other words, if a quadrilateral is inscribed inside a circle, then this quadrilateral is actually a cyclic quadrilateral. Now, we'll use the same property here. If a parallelogram is inscribed inside a circle, mark the words. If a parallelogram is inscribed inside a circle, let's draw a circle, and inside this circle, I am drawing a parallelogram. Obviously, it is not looking like a parallelogram. It is a rhombus, but I have just made it purposely. Sorry, it's looking like an isosceles trapezium, but I have just made a parallelogram, and let's consider this a parallelogram. So, P, Q, R, S. Now, if it is a parallelogram, it simply means this angle, these 2 angles are equal because opposite angles are equal. At the same time, these 2 angles are adding to 180 degree because this is a cyclic parallelogram. So, if the parallelogram is cyclic, opposite angles will become 90 degree. So, if one angle is 90, automatically a parallelogram will become a rectangle. It means the moment a parallelogram is inscribed inside a circle, this parallelogram will become a rectangle. So, inscribed inside a circle. Is it clear? If a parallelogram inscribed inside a circle, it is a rectangle. Any doubt?
No.
Okay. Come to the now. How a rectangle will become a rhombus?
Excuse me, sir.
Yeah, tell me.
You said a rectangle will become a rhombus. It will be a parallelogram will become a rhombus.
Oh yes. How a parallelogram will become a rhombus? Exactly. Let's consider a case where there is a circle, and now we are making a parallelogram outside this circle, or a circle inscribed inside a parallelogram. In previous case, circle was outer, parallelogram was inside. Now circle is inside, parallelogram is outside. So if a parallelogram is outside this circle, it will be like this. Now if this is a PQRS, if this is a parallelogram, then what this parallelogram will be? Rhombus, rectangle, or a square? If a parallelogram is circumscribed about a circle, circumscribed outside the circle, then this parallelogram is a rhombus. The question is how? For this, we have to use one property from circle, where from any one point, two tangents drawn are always equal. Let me make this figure a little bit bigger. This is a circle, and this is a parallelogram. Let's assume it is touching. So if I consider from S, from this point there are two tangents. So both of these two tangents are always equal. From one point outside the circle, exactly two tangents can be drawn, and both the tangents are always equal. I am taking a property from circle just to prove it. So these two equal. Similarly, these two small parts equal, this equal, and these two parts also equal. Whereas this plus this, these two adding to one, this complete length, and now these two parts are also equal. So when we will add these two and will add these two, RS and QR both will become equal because of this property. Automatically SR is equal to QR. Now adjacent sides are equal, so this will reduce down to this. Means whenever a parallelogram is circumscribed about a circle, then this parallelogram is a rhombus. Okay. Now, when a rhombus will become a square, now this property. If a rhombus is inside a circle, it's a square, same process. And when a rectangle is circumscribed about a circle, this is a square. So this property again we will use here, and if you will use this property here, in that case, this rhombus will become a square and a rectangle will become a square. So there are three cases, two which we have seen previously and one. Now this inscribing and circumscribing is a property which is changing these rectangles and rhombuses and parallelograms to a different figure. Clear? Thank you.